Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll use the concepts of oblique asymptotes to solve this problem. So as per the problem, determine the equation of oblique asymptote for each of the following. Determine the direction from which the curve approaches the asymptote. So let's start by finding the equation of the oblique asymptote. So we'll start with the function on the left side. So to find the oblique asymptote, we'll have to do the polynomial division for this rational function. So we have to divide the numerator, which is called the dividend, by the denominator, which is called the divisor. Now there are two ways to do polynomial division. So we can either do long division or synthetic division. So for this rational function, we can do synthetic division. Now for synthetic division, we only have to use the coefficients from the dividend. And we have to set the divisor equal to 0 to find the root of the divisor. So let's start with that. So we'll set x minus 3 equal to 0 and then solve for x. So we add 3 to both sides. So the 3's on the left side get cancelled out. So we get x equals 3. Now we can do the synthetic division. Now the coefficients of the dividend are 3, -2 and -17. And we'll put the root of the divisor on the outside, on the left side. So for the first step, we'll move the 3 down. Now we do 3 times 3, which is equal to 9, and we put the result under the -2. Now we add the numbers in the column, so -2 plus 9 equals 7. Now we multiply the root of the divisor, which is 3, by 7, which is 21, and we put the result under the -17. And now we add the numbers in this column, so -17 plus 21 is equal to 4. So 4 represents the remainder of this division. Now since the degree of the quotient in this case will be 1 less than the degree of the dividend, because the degree of the quotient is basically the degree of the dividend minus degree of the divisor, which is 2 minus 1, which is equal to 1. So 3 and 7 represents the coefficients of the quotient, so we put the x with the 3. So the result of this division can be written as 3x plus 7 plus 4 over the divisor, x minus 3. So this is the function f at x. Now in this function, the 3x plus 7 represents the equation of the oblique asymptote. The oblique asymptote is y equals 3x plus 7. So this should be the final answer to the first part of the problem. Now we have to find the direction from which the curve approaches the asymptote, and for that we'll have to analyze this part of the expression for f at x. So if this fraction is greater than 0 for an x value, for a big x value, That means the curve approaches the asymptote from above, and if this value is less than 0, that means the curve approaches the asymptote from below. So we'll have to evaluate the limit. So let's start with the limit on the left side. So we'll use a big negative number. Limit x approaches the negative 100. So 4 over x minus 3. So if we apply the limit, so we get 4 over negative 100 minus 3, and which is equal to 4 over negative 103, which will give us a negative result. That means on the left side, so the curve approaches from below. So there is a very important concept we need to understand and memorize. Now we can analyze the limit on the other side of x-axis. So limit x approaches positive 100. So 4 over x minus 3. So now we can apply the limit. So 4 over 100 minus 3 is equal to 4 over 97, which gives us a positive. That means the curve approaches from above. So there is a very important concept we need to understand and memorize. So the reason why a negative value makes the approach from below is because then we have to subtract the value of this fraction from the value that we get for that x value from the equation of the oblique asymptote. And for the positive result, we have to add that result to the value that we get for y from the equation of the oblique asymptote. So now we are done with our analysis for the first function. So now we can analyze the second function. So for this function, we have to do the polynomial division. So the numerator is the dividend, denominator is the divisor. So for this rational function, we can do polynomial long division. So we can do the setup like this: so 2x squared plus 9x plus 2, and then the divisor outside on the left side. Now we have to find the quotient. So for that, we'll divide the first term of the dividend by the first term of the divisor. So 2x squared divided by 2x is equal to x. So that's the first term of the quotient. So we'll multiply the divisor by x. So 2x times x is 2x squared, and then 3 times x is 3x. Now we'll subtract the terms. So the x squared terms will get cancelled out, and 9x minus 3x is equal to 6x. Now we can bring down the 2. Now for the next term in the quotient, we'll divide 6x by 2x, which is equal to 3. So the second term is 3. Now we'll multiply the divisor by 3. So 3 times 2 is 6, so 6x, and 3 times 3 is 9. Now we can subtract the terms. So the 6x terms get cancelled out, and 2 minus 9 is negative 7. So negative 7 is the remainder of this polynomial division. So we can rewrite our function as f at x equals the quotient x plus 3, and then plus negative 7 over 2x plus 3. So the equation of the oblique asymptote is y equals x plus 3. So this should be the final answer for part A. Now we have to determine the direction from which the curve approaches this oblique asymptote. So for that, we'll analyze this fraction in the expression for the function. So if we get a positive value for this function, for this fraction, then that means the curve approaches the oblique asymptote from above. And if we get a negative value, that means it approaches the asymptote from below. So we can do the limit test. So let's start with the left side. So limit x approaches negative 100. So we have to use a big negative number. So negative 7 over 2x plus 3. Now we can apply the limit. So negative 7 over 2 times negative 100 plus 3. So the numerator is a negative value. The denominator will also be negative. So 2 times negative 100 is negative 200. And negative 200 plus 3 is negative 197. So the overall value will be positive. So the conclusion will be that on the left side, so the curve approaches from above. Now we can do the analysis for the right side. So limit x approaches positive 100. So negative 7 over 2x plus 3. So negative 7 over 2 times 100 plus 3. So we have a negative value in the numerator, and 2 times 100 is 200 plus 3 is 203. So we'll get a negative value. That means the curve approaches from below on the right side. So this should be the final answer for the second function. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.